Hey, in this tutorial we're looking at section 13.5, which is on mixed probability application problems. Okay, so often application questions involving normal and standard normal distributions may also require other areas of probability, such as binomial distributions. Okay, so I've got worked example 6 to give you an idea of what we mean by this. So, we've got the amount of instant porridge oats in a packet, in packets packed by a particular machine is normally distributed with a mean of mu, okay, and a standard deviation of 6 grams. Okay, the advertised weight of the packet is 500 grams. So tell us that it's 500 grams. Okay, find the proportion of packets that will be underweight, so less than 500 grams. Okay, when mu equals 505. Okay, so what we need to do there is we're basically saying, well, we want to find the probability that x is less than 500, okay, when mu equals 505 and sigma equals 6. Well, that would just be an inverse normal question. Okay, so we'll do our inverse normal to find, no, sorry, it won't be inverse normal, it'll just be normal distribution, sorry, not the inverse normal. Okay, and so we find that we get a value of equal to 0.2023. Okay, for part B, we want to find the value of mu required to ensure that only 1% of packets are underweight. So basically we're saying, well, we want this time the probability that x is less than 500, okay, to be equal to 0.01. Okay, so what we do then is we need to, like we did in 13.4, find an equivalent z value. Okay, so that equals 0.01. Okay, so we'll do our inverse normal in our calculator and we'll find that our z value is minus 2.3263. Remember, when doing inverse normal to find this, okay, we need to set our mean to be 0 and our standard deviation 1. Okay, so now that we've got our z value, we can use our z equals x minus mu on sigma. Okay, well, I'll come up here, so our z, sorry, was our negative 2.3263. It's equal to our x value, which was our 500, minus mu on sigma, which is 6. Okay, so when we rearrange, okay, we find that mu has to be 513.96 grams. Okay, so our average would need to be 513 to ensure that only 1% of the product produced is less than the advertised 500 grams. Okay. Part C, okay, is as a check on the setting of the machine, a random sample of 5 boxes is chosen and the setting is changed if more than one of them is underweight. Find the probability that the setting on the machine is changed when mu equals 505. Okay, so what we're saying, okay, then, okay, is the wording of the question, a sample of 5 boxes, indicates that it's now binomial distribution. Okay, so that means, okay, that we're talking about having, when we had our mean of 505, well, the probability that we were underweight was our 0.2023. Okay, so basically we're now saying, well, we can say we won't use x as our random, as our variable, or z. Okay, so let's use y. So we're really saying that y is binomially distributed. Okay, and our number of trials is 5. Our probability of success is 0.2023. Okay, so we want to know, okay, find the probability that the setting on the machine is changed. Okay, so it'll be changed if we're above 1. Okay, so it'll be changed if we're above 1. So we want to know what the probability of y being bigger than 1 is. Okay, which is going to be the same as probability of 1 minus the probability of y being less than 1. Okay, So we can use our calculator here, okay, if we like, or we could do our 1 minus, well, it'll be 5 choose 0, okay, times our probability of success, which is 0.2023 to the 5 times our 1 minus 0.2023 to the 1, okay, minus our 5 choose 1, 0.2023 to the 4, and our 1 minus our 0.2023 to the, sorry, that one should have been, I don't know why I did that, that should have been 0 up there, okay, to the 1, so I did that around the wrong way, okay, and when we do that, okay, we find that the probability is 0.2674. Okay, of course you could just use our calculator to do our binomial distribution to find this. Okay, we wouldn't need to go through this process of doing it by hand. Okay, so that's all there is for this section. So I really don't think you'll have too much trouble with this. You'll just start off by having to do some normal type questions, and then there'll be something like what we've just done at the end, okay, where we need to use something else like the binomial distribution.